I'm Luther Kruger, Big Blue Sun Museum of Solar Cooking, based in Minneapolis, Minnesota. And I'm in the Albuquerque leg of my tour of videos talking about solar cooking and related topics with folks. And I'll let my guest introduce himself because he's got past in solar cooking, solar energy.
Dave Menicucci, and right now I'm doing work at the University of New Mexico, research professor in mechanical engineering, and focusing on solar.
Sure.
So we've got a number of projects going on right now. We'll talk about them in a bit.
Yeah. Well, and I always have just 3 open-ended questions because I learn the most when I hear the stories, I hear the backgrounds. And the first one always is, how did you discover solar energy in any way, shape, or form? And then specifically, how did that lead to solar cooking?
Well, that was easy. I mean, the solar energy was seen back in the late 70s as one of the solutions to our oil problem at that time. And I was just finishing up education, and I thought this would be cool. Sandia had a really robust program. They were an important part of the national effort to deal with this problem, and that's how I got involved in it. I just thought it was really cool, and that's how it started.
Sure.
Started in photovoltaics and went over to solar thermal. And as part of that, I was running a forensic group at Sandia. So we were involved in mostly military, but it was all energy. But part of it was DOE funded, so we were able to help people, and we were directly helping manufacturers. And I got a call one day from Tom Burns, who said, "Hey, I know you've got this assistance thing going, and wondered if you could help me with this design." He was having a number of problems with the cooker. Had to do with the reflectivity and some stuff that Sandia could address. So we did. We took it on, and we helped make some improvements. We have a manufacturing facility at Sandia doing research. They helped out. And then we got involved in the Villager because Tom made the Villager too. And we thought, well, this would be a good application for some larger organizations. And we actually tried it at there's a monastery up in northern New Mexico, totally off-grid, called Christ in the Desert Monastery. And they were interested in trying it out, and they sure did. We took it up there, and we had instrumented it, and they were trying it and using it, and ultimately we just couldn't provide enough support to get it over the hill that they would adopt it, but they used it for a while. And I think it would have worked if we'd have just been able to work with them a little bit longer, but there was a limit to what I could do. But anyway, that's how I got into it. And
Sure.
now we're involved in all kinds of stuff now, especially the greenhouse.
Well, and back to the Villager, because I remember hearing that Sandia was involved. So you're the guy.
I'm
right?
the guy. I'm the guy.
I'm so glad because
I'm the guy. Yeah.
You made that happen.
Yeah. Well, we had at one time with the Villager, it was Christmas time, I think, and the two of us, there were 2 researchers out there, Earl Rush and myself. We just said, why don't we do a turkey for the whole, and there was like 30 people in our group. And we had a test facility, so we had the Villager there, opened it up. Earl liked to cook, I liked to cook, and we cooked a full meal for 30 people at the solar power tower at Sandia Labs, and we published a report. I can't believe I published a technical report on this stuff. It's unbelievable.
It brings to mind one thought I've had is that if there could be a group that could put together what are the best practices for community cookers, ones that cook large volumes. There's the fellow in India who has he's taken back the whole campus, and it's entirely solar powered, and massive reflectors that heat up water to boiling, and then that does some of the cooking as well as heating the place. Anyway, so
the most important thing with any of these devices in an organization is to have somebody dedicated to it.
Yeah.
In other words, you've gotta have somebody in charge of the cooker, otherwise it just won't be used. So, and the cook is typically kind of your first line, but cooks are not accustomed to that because they're used to turning on the oven, it's a certain temperature, it goes in, it stays a certain amount of time, and then you take it out. Well, some foods, you can put it in at a lower temperature and it just takes longer to cook. But it's the lack of consistency that you have to deal with. The sun doesn't shine every day, the temperature is a little different, the amount of food you're gonna cook varies from day to day, the type of food varies. So there's a lot of things that would affect how long it's gonna cook, and you have to do something that maybe is not, people don't do a lot of these days. They have to actually think it out, reason it out. We have a lot of sun today, good solar time. We're gonna get maybe rain this afternoon, we better cook in the morning. That's the kind of thinking. That's not, we're not talking about differential equations, we're talking about fundamental stuff.
Yeah.
So that's what we try to get through to people. And it's different. It's different from the standard cooking, but Barbara and I do it all the time. I mean, for us, this isn't a big deal. But it's not complicated. It's just different.
Yes.
Yeah.
And so you've had this is probably one of the first models of the sun oven.
This is the
from way
third
back.
one. We've worn out.
No, yeah. It's
Yeah. We've worn out one totally. The
Sure.
other one, the second one we got was up at our cabin.
Okay, yes.
And we use it up there. This one is the third one. And I got this from Rose Kern. Yeah, she's quite a writer, and she's published a book on solar cooking.
Yeah.
In fact, one of my recipes is in there.
There we go.
Yeah.
Yeah. No, we had a good chat with her, and her she's raising chickens, I think, and she's got a regular. I mean, the garden is so productive in her backyard, and yeah.
It's not high tech. You
No.
don't have to know differential equations to get into this stuff.
No.
You've got it's fairly simple, but you do have to think.
Yep.
Because the sun isn't constant, and you get clouds, and you have to deal with that.
Yeah.
It's not hard, but it's something different.
Yeah.
If we could get some cooperation between the architects and the engineers, initially, we wouldn't end up with designs that the architect comes up with and that the engineer has to design to regardless of the energy. So that's the whole idea. And I think the same thing with the solar cooking. This is something people could use. We were talking about even in a high rise. If you've got a south facing building and you've got some sun and you've got a balcony, you can probably do this. So it's a very useful product. And it keeps your kitchen from getting
Yes.
hot in the summertime. That's the
Yep.
biggest thing.
Well, and my biggest benefit for me is it gets me out of the house to do weeding, the honey-do list, fix that cracked up or tilting fence post, get some painting done. Well, so tell me about the project over our shoulder here, and then we'll move the cameras over there in a little bit to get a little closer look.
Yeah, what I'm doing here is something that is driven by the need for creating a food source and an oxygen source as we travel from here to Mars. So the professor who lives just down his house down from us here, Dave Hansen, he and I have collaborated on this greenhouse to create what we think is, and this is all my design and the engineering, glass and mass greenhouse that can produce meaningful amounts of food year-round. So that's what we're demonstrating right here, is that we can do this year-round, and we can do it economically, and it's in a structure that almost anybody can build, because it's all common materials. One of the goals of this construction, the design, was that it has to be built with materials that you can buy either online, eBay, Amazon, whatever, or you go down to Home Depot or Lowe's and get the materials. So everything in the greenhouse is like, now the greenhouse is structured specifically so that we can run experiments that would be typical of those that would be in place on a spaceship that's going to Mars. So it produces not only the amount of food you need, it processes your waste, and it produces oxygen and consumes carbon dioxide on the vessel. So this promises to be the answer to these very long journeys in space. This is what we're calling a controlled outdoor space, because it's not totally controlled like indoors where you precise temperature control. This is allowed to fluctuate, but we terminate it at certain points. We don't want it to get over 100 degrees F, and we don't want it to get below 32 F. So we want to hold it within there, but it can vary within that range pretty freely. But we've already run through a very cold winter, and, well, at least the second part of the winter was very cold. And I had seedlings in there. I had tomato seedlings in there. This was in early February of 22. I had tomato seedlings that big, and all I did was cover them with a piece of plastic. The next morning I went out there and they were fine. Barbara, I was gone. Barbara went out there a couple times. I called her and I said, "Are they all frozen up?" And she said, "No, you went in there and it was nice and warm, and this was a winter morning."
Sure.
You know, and so that's what we're going to do, is going to be running some experiments in there. So Dave is designing the experiments. I'm also promoting this as something that almost anybody can do in the backyard. And if you look at this area here, you can't see it, the camera's here, but we live in one of the biggest cottonwood forests in the world, right here in the Rio Grande Valley. And we are right in the heart of it right here. Sure. Everyone was telling me, "Oh, you can't do this here." And I was saying, "But I got radiation here." I mean, you know, so an engineer just says, "How much radiation do I have to work with?" That's what I use. And that's what we did here. So even though I've got a big tree there, that's a 60-foot tree. That's a cottonwood. There's another one right there. Got this 2-story house that we live in. We're just surrounded, but I get enough clear sky, and especially in the summertime, where these leaves fall off. So I'm getting some radiation through there. These will all have leaves falling off. They'll be bare. Radiation will get through. That tree in the front there loses leaves. In fact, I don't know if you noticed, the trees in front are specifically trimmed to be canopies.
Oh, sure.
And I trim off the bottom part, because in the wintertime, the sun comes through and heats our solarium.
Sure.
So this here, this greenhouse, is part of, Dave thinks he maybe get a $2 million program. This wouldn't just for this, but part of it would be controlled experiments right in here. So one of the goals here is to develop a thermodynamic model for this greenhouse. Use this to verify the model, and we're going to do that in ANSYS, which is the most modern of the simulation software. And so we'll be using the weather data from the National Renewable Energy Lab, the typical meteorological year data, which we've got like 400 stations, I think, throughout the United States. So we're going to use all of that, and part of that is going to be for the Mars mission.
Sure.
And that's hot right now.
Oh, yeah.
And so is the greenhouse hot. I mean, they even did a story about this in the Neighborhood Association newsletter. I was in there. So, yeah. So I picture of me having a bunch of radishes on January 10th or something. I picked out, I had a big bunch of radishes. Yep.
Well,
Anyway, does that answer your question?
Oh, yeah, and I like adding, some people, they watch my videos and they say, well, they stopped talking about solar cooking at about 10 minutes in, and then they picked it up again. It's like, what was that about? And they're going, it's solar. I love hearing the new solar applications, and space. There's no clouds in space.
Yeah. No. That's the nice thing. I mean, one of the biggest problems we have here on Earth is we got to deal with clouds.
Yeah.
And
clouds, seasons, and night.
Yeah, and night. And you don't have any of that out in space.
Yeah. I was thinking before we go over there, if we could, now that the sun has come out a little bit and it's not raining, we could step over to the sun oven, and if you can just remember whatever processes went into designing that with Sandia and so forth.
Oh, yeah.
Yeah.
Okay.
Yeah, so the sun oven and Sandia.
We were working with them on this Mylar film. That was because Sandia had a program to make heliostats out of a membrane, And what it would do is it would stretch this membrane around a circular housing, and it would pull a vacuum on it. And when you pull a vacuum on it, it makes a perfect parabolic shape. And we use that to focus on the power tower. So we had a field of heliostats, and we were testing various ones with different kinds of reflective film, and we were able to apply what we were learning there to the oven. We also helped him with some of the insulation on this. So this was early in the design that we were working on. He also had some contraptions where you had lights on here that were electric lights for when the sun wasn't shining.
Are we talking Tom Burns, you mean?
Yeah, Tom Burns, and we convinced him that was kind of a dumb idea.
That was
Yeah.
the more you add on, the more complicated.
Yeah, so those were the kind of things that we were helping. And then we helped him, we have an advanced manufacturing facility, and they took a look at his manufacturing facility and made some recommendations on how he could improve the manufacturing and so forth. Raised a few real hackles there a little bit, but Tom was in back of all of this. So
Sure.
he made some changes, and I think he got the cost down a little bit. It was up about $600 at the time, and I think he got it down to about $300 is what we paid for, 400 something.
I seem to recall seeing ads for it, like in the back of like Popular Mechanics, Popular Science, and in the 250 to 350 range.
And really back then, that was back in the 80s. That
Yeah.
$400, $500. That was a considerable amount of money.
They're pricey.
But now I think they're $250, something like that. So I think they're well worth it. I mean, if nothing else, it's certainly a lot of fun. But we use it for actual cooking.
Yeah.
But this was a fun project to work on. It was way off the beaten path from our ordinary military work, and we had a heck of a time with this. We worked on the Big Villager too. The Big Villager, we doing the same kind of things, looking at the reflection, and we also did some modeling on the angles and so forth and stuff like that. I mean, it's typical engineering research kind of
And
thing.
it's basically this scaled up.
Yes.
And more of a barrel to hold it all together. And
Yes.
Yeah,
yes.
and rather than there's the bolts for the axis, the whole thing rests on the axis, including the cook space, so you can turn the reflectors, but you don't tip over the bread pan.
Yeah. And all of this work was done at the National Solar Thermal Test Facility at Sandia, which is the home of the power tower. And of course, we had all the technicians and equipment and then test equipment and everything, and they were there available to help us. So, we had a full team. And I had a team. My team was like four people on my team. 3 of them were full time, and 1 guy was just helping out. So I mean, it kept us plenty busy, and this was just a huge diversion, and it was so much fun.
Oh, yeah.
Especially making Christmas dinner for the entire staff at the tower.
Sure.
Yeah. So anything else you want to know about this?
Well, you mentioned Mylar, but this is, correct me if I'm wrong.
This is aluminum.
Yeah, it's what they
This
call
is polished aluminum.
Yeah, spectral grade is what I've seen.
We were
sometimes.
looking. See, my dad, when he built his, he did his with Mylar, and it was high quality, very reflective Mylar. This is not as reflective, but it's so simple and it's so cheap.
Yeah.
And it's easy to manufacture.
Well, and for my money, or my understanding and my experience with all the cookers I have that have aluminized Mylar for reflectors, these will last forever. Aluminized Mylar, not so much. It degrades over time.
Yeah, well, there's a whole bunch of different types of films, and we were looking at all of them because we had been using them out on the heliostats.
Yeah.
So we just played with what we had to play with.
Sure.
You want to know the truth? It was a huge diversion and a great deal of fun, and we were dealing with solar energy, and we were in the solar energy business, just not in the cooking business. And Sandia is a research engineering laboratory, so when they hire researchers, they expect us to go out and get work and then conduct it. And we have research technicians who will assist us as required. But basically, our job is to have as much fun as we can and do something useful for the world. That's exactly what we do. So it's a tough place to work, I will say this. It's a very, very competitive and very rough, demanding place.
The one question was with Rose Kern and Andrew Stone was they weren't sure if the end product of the villager, if they just made one, or if they made more than one there at Sandia before?
No, we had two at one
two?
time. Yeah,
Okay,
we had two.
okay.
We had one at the facility, and we had one in the field.
Okay.
We had one up at the Christ in the Desert Monastery for a while, but we had it in different places too. And then we loaned one out to the Solar Energy Association. Didn't you guys? Yeah, you guys. Yeah. Yeah.
Well, and I'll get a hold of that monastery. I won't be able to do it this trip, but I'll be retiring in about 8
Yeah, I
months.
don't know. I know I haven't been up there in a long time, so
Yeah.
I don't know what the status is. There may
Yeah.
not even be anybody there. That
Oh, no.
I actually ended up going up there for a retreat.
Uh-huh.
You could do that.
Yeah.
I can go up there right now.
Do they have a phone? It can even be a landline.
Yeah,
or
just they've got email.
email. Okay.
They
That's
are
it.
the scriptorium for the Pontiff.
Oh my goodness.
You know, when the Pontiff puts out all of these newsletters and
Sure.
stuff, they are on the team because the Benedictines have been doing script work for centuries.
Oh my goodness.
I think it's 7 centuries.
Wow.
Benedict.
Something like that.
Something like that. Yeah. So that.
Okay.
Yeah.
Well, it's not like they've run out of work.
No. Well, this is. Let me just show you how we package this up. How easy it is.
Yeah.
That's
Good
it.
deal.
That's
Good deal.
it.
Yep.
That's all there is to it. And we put it right there, and we sit. If it sits this way, there's south,
Yep.
and there's a big open area there in the summertime. The sun comes right
Oh,
across
sure.
here, and we get a good. What would you say? 6-7 hours
6 hours,
every
yeah.
day.
Oh, yeah.
Something like that. It's plenty, and we get 350 F in there
Oh, yeah.
consistently.
Yeah.
So it cooks just about anything. And it tenderizes. I'm telling you, I could put a shoe in there and it just would tenderize. Yep.
All right. Well,
Yeah.
let's move to the greenhouse, which definitely piqued my interest. Oh, we are in the greenhouse.
Yeah. This is a solar-only glass and mass greenhouse. It's specifically designed with the intention that the goal is to have meaningful food production throughout the year using solar only. So everything in the greenhouse is powered with solar, notwithstanding all of the energy it took to produce everything here, but it's all operationally, it's solar only. So I've got a photovoltaic panel just to run a thermally controlled exhaust fan, and I've got an automatic, mechanically automatic, that opens automatically. That's commercially available.
Is that it's like wax in that?
Yeah, there's
there's
actually a fluid in there,
Yeah.
and it just expands and contracts when this warms up. So
Yeah.
this right here is here's the tube that contains the fluid right here,
Okay.
and that's all it is. And that will automatic, and this stuff is all available on Amazon or eBay. One of my goals in designing this is that this has to be built with no esoteric materials, just common materials that you can get at Home Depot or Lowe's or Amazon or eBay, but I don't want to have any. I mean, for example, that control box, it's all analog, and I designed it like that instead of digital because anybody can build that. This is more complicated than it needs to be because I'm an engineer and I like to, I want to
Well,
have all of the data.
You're going to collect the data
Yeah.
that the other the folks who replicate this won't need to
They
do.
won't need that.
Because they'll have the data will have been built into the design.
So,
Yes.
so you only need about 1/4 of the equipment you've got here, and it's all commercially available, and it doesn't have to be in a box, and you don't need all the meters, and all you need is a battery and a couple of devices, and this will work. So this is a collaborative project with the UNM Biology Department, with the UNM Mechanical Engineering and Biology, and UNM Biology Departments are collaborating on this greenhouse project. And one of the goals here is to develop not only a greenhouse that can produce food year-round and is applicable in almost any area, but we're also going to be doing some experiments relative to Mars missions. So we've got to have some way of producing food on the way to Mars, producing oxygen on the way to Mars,
processing human waste on the way to Mars. So all of that has to be done in a closed environment, and we call this a controlled outdoor space for experimentation. So this allows us to somewhat control the space. So it's an outdoor space, not an indoor space with precise control. It's an outdoor space, but we have limits. We don't want to get over 100 degrees F, and we don't want to get below 32. And so far, it has performed beautifully. So, in fact, it's performed beyond my expectations, as in the engineering expectations.
Hear about through the wall of it. There's a woman, I don't know where she lives, but she's on a YouTube channel, is Frugal Green Girl, all one word, Frugal Green Girl, and she made one that just sticks out of her living room window.
Yep.
With greenhouse glass, just like this. It's just
Yep.
you know.
Yeah,
and,
this is just polycarbonate.
Yeah, and then the glass, the door to put the food out through is just her window, and she just closes it. And
Yep.
it's about $250, and she's made sure that the materials around the window aren't destroyed, and they've held up.
Yeah.
So she's
Well,
able to
see,
do that thing.
see all of these windows here that I've
Yeah.
got? Those are all windows that were in our house before we did the remodel.
There we go.
I just reapplied it.
Yep.
I tried to reapply as much as I could
Yep.
on all of this. But it works extremely well. There's so much mass here that even in the summertime, it's collecting a lot of solar energy.
Yeah.
And it's collecting a lot of, not solar energy, it's collecting a lot of heat. And so what I'm hoping is that we're gonna see some seasonal carryover. In other words, this is still cool from the winter time, and it's slowly warming up. By the end of summer, it should be very warm, and as we get into the cooling time, it's gonna lag behind the actual outdoor temperature by probably 4 to 6 months. So we're gonna see minimum temperatures here sometime in the early summer, maximum temperatures sometime in the early winter. So we want that lag, and that will carry us through the winter, and it will also carry us through the summer. So it's already moderating the temperatures. I'm able to keep the temperature in here well under control just with the fan and the open windows. But you notice how I have it designed. It's open on all 4 areas here so that the air can infiltrate no matter which direction the wind is from. If it's from that direction, got 2 windows here open, 2 windows here. If it comes from the south, we've got this window and the door and that door. And by the way, that door is reapplied. That was from our front porch too.
Here we go.
So all of this, I mean, a lot of this stuff, I just reapplied it here.
Well, now, and speaking of materials in the space aspect, I can see where it's compartmentalized, where theoretically you could say, well, we're not going to have this polycarbonate up
Right.
on that thing halfway from here to Mars,
Right.
but you can replace it with whatever they have, right? I mean,
Yeah.
is that going to be part of the?
Yes, well, we're not quite to that point
Sure.
yet. We're still at the conceptual stage,
Yeah.
so we haven't gotten to exactly how this is gonna be implemented. But what Dave wants to do is run some experiments where we've got a very controlled space, and we've got very controlled resources, and then to measure it, the soil temperatures, and see what it does. So he's designing some experiments, and yeah, we're gonna play it out as it goes, and eventually we will get to that point where we say, what materials do we use for design? And that, again, the engineers will get involved in that part. So this is a really good collaboration with the sciences, between the engineering and sciences, and I love it.
Yeah.
So, I mean, I don't like to be compartmentalized. I like to spread out and do a whole bunch of different things.
Sure.
So this works out great.
Question about your cap there. We got to talk about the solar splash a little more. You
Oh,
talked a little bit
yeah.
about it, but
Solar Splash is our capstone program at UNM. Every student at UNM, every senior student must do a capstone project. They can do their own, or there's a couple of programs that are ongoing programs at UNM. One is the CAR program that is sponsored by the Society of American Engineers, SAE. And in that, what they do is they build an actual race car. So this is a standard engine race car, very mechanical. The Solar Splash is an alternative to that. So the students can
engage in a project where they build a solar-powered boat, it has to be occupied by a person. It can only be, the total power has to come from photovoltaics. They actually run it in competition, international competition. So the students build a boat. We have regular design reviews, just like we would at Sandia or anywhere else where we're designing something. We have regular design review. They actually build it. They build test plans. They take it out on the lake and test it. Then they take it and compete. And this year we came in third. So we're steadily, every year, we're just making incremental improvements. And I expect one of these days we're going to be number one. Because UNM engineering kicks.
Not a monopoly on sunlight, but you got a pretty good steady source.
Yeah, and if you come in here, you can kind of see what I'm talking about
yeah.
relative to the sun. You look at this, and somebody would say, "You live in a forest." Well, during the winter time, the sun gets up right over there, and it comes and stays right under this tree. It goes right over there toward the house, and it sets right over there, and we get tremendous afternoon sun in here. Just and it. You come out here during. In fact, I've got a couple of infrared images. I should send them to you.
Yes.
And it shows in the middle of winter time, these beds are just glowing red with heat, and it's cold out. It's maybe 20 degrees outside, and you take a picture of this and you see just these beds as hot. So it's really clear that this is. But I've got the mass goes all the way down. I mean, this from right here, the insulation on this, the mass goes down about 2.5 feet. So it's all the way down in here. So and this is fully automated right now. I can go off to the cabin. Barbara and I go off for a weekend to the cabin. This takes care of itself. It automatically waters. These are all. I don't know if you've seen these. These are all these little. You buy them.
Oh yeah.
They're programmable. They're battery powered.
Yeah.
They're just it's so simple. And I've been testing them. They'll work for a year, turning on and off water on one set of batteries. So I'm using them. They're not quite as sophisticated, but again, I'm trying to keep this as simple as possible so that people don't have an excuse to say, "Oh, it's too complicated for me. I can't do that kind of stuff." This is going to be producing food year round. I mean, we were taking lettuce out of here almost every other day. We were getting a big bowl of. I mean, we got tired of eating nothing but it's so good.
A salad at every meal.
Oh, but we were making meals out of salads.
Okay.
I mean, we were having like chef salads, and it was just tremendous amount. Right here, I had peas, and I was measuring how much we were actually harvesting. And then snow peas, yeah. We had peas. We got, based on the arable area, now this is a little bit hokey, but based on the arable area, we have twice the production per arable area from here as you do in a commercial farm. So the point is not, that's a hokey comparison because the scale is so different. But the point is that it's possible to produce meaningful amounts of food from a place like this. And this wasn't expensive. I think we're going about $6,000 or $7,000 on this. I mean, all of this was just built by hand from my design. And in fact, I will have a detailed design. I've got drawings for the original, but now I'm going back and doing the as-builts. I'm going to have the architect redraw that, so we've got a good PDF drawing of details, architectural drawing of the details of this that we're going to use as part of the proposal that we're going to put in for the grant.
And how deep is the soil in this?
The soil, this soil goes down about, see this block right here?
Yep.
Another block underneath that, that's the end of the soil. So all of this is growing soil in here.
Okay.
So we can get in here, and these will tilt up, so you can get in here and re-till every year. And I just built these, designed and built all of this myself. I've got a shop that, I've got welding equipment and everything. So, yeah, but I'm really, these are wild raspberries that grow up at our ranch in our cabin. I take them down here and they're doing just fine. So this is just a lot of fun. Barbara likes to come out and pick beans.
Why not?
We've got what, 3 harvests so far, about
eight ounces of harvest. We've got about
Yeah.
24 ounces so far of beans.
Yeah.
But you can see them here, Luther. They're obviously happy little critters. They're putting out beans like crazy. And the rule here is nothing non-organic in the greenhouse. Everything that we put around the plants has to be organic. I use standard fertilizers on the perimeter on the outside just to keep cockroaches and stuff like that, and ants and things like that under control. But everything in here is organic. It's totally organic inside here.
The challenges have been fun. I mean, this is great stuff.
It's the name of the game.
Yep. I'm having fun. That's
Yeah.
all.
What's the next obstacle that can walk in your path, and how quick can you bat it away?
No,
Find the
we
solution.
got plenty of obstacles. We got all kinds, and that's the favorite thing for engineers. We got problems to solve. So, I hope that answers your questions.
Oh no, this is great. Way more than I expected.
What-
I
what else?
I definitely knew. I knew there was going to be something about a greenhouse, but connected with the space program and everything, and all in the solar aspect. That's the main thing.
The other
question?
No, I think that'll cover it. Thank you so much.
Oh, you're very welcome.
Yeah.
Yeah. Anytime you want to come back,
Yeah.
we'll
Well-
be making progress unless I die.